First of all, thank you all. I know a bunch of you have followed us over from our last presentation at 10 o'clock Eastern, where we talked about, user-defined protocol, user-defined policies and extensions. And now we're going to move on to how do we, reimagining data power in the container world, which is basically, we have a huge history with data power, right? A great history where we've had our physical appliances, blah, blah, blah. And then we're going to we'll talk about that briefly and the DevOps history. And then we're going to go over the new DataPower operators. One thing we haven't really talked about much in the past, how do we develop for DataPower containers? How do we build the DevOps pipeline? What are the best practices involved in all this? So Aidan will be taking us through this. He's really our chief developer of all these technologies and, a great resource. So I don't want to spend too much time on this. I want to really let Aidan dive into the meat of technical content as one of our top-end developers here. But as you all know, right, we started from DataPower a long time ago as a physical appliance. And as we move as a journey, and as you move your journey towards containers and public clouds, right? Now we still have DataPower in all these form factors, so no worries there, and we have plans for all of them. But as we move this journey towards the public cloud, right, we move DataPowers into a containerized form factor. This basically allows us to use a more modern, developer-focused DevOps pipeline. It allows us to add in more and more capabilities as far as the monitoring and the deployment of your gateways using things when you have OpenShift containers or Kubernetes, alongside the operator framework. So very important there. Whoops. Maybe Aidan, you want to move forward for me? I'm having an interface problem. Typically, right, in the past, I know many of you have been DataPower users for a while, looking at this group of distinguished guests we have in this room from the DataPower world. You basically today, whether it be, my physical DataPower or a VMware style DataPower, right? DataPower configurations are persistent on a file system inside the box, in a sense, in a flash drive or a virtual flash drive, let's call it in VMware, right? And you do your development in the web GUI and work with that. You programmatically modify your configuration, sometimes using this command line interface and the SOAP management interface or the REST management interface. And so when I move my domain specific things, I can either have command line interfaces to do those things, or I have something called deployment policy objects. And these are, I export a policy from a development environment, I import it into a test, I export into an acceptance, import into all the way through to production. And I can have these templated policies that change specific environment level information. So it's a very effective DevOps pipeline. It works very well, but it is very specific at the same time to DataPower and to the history of DataPower and what it does. When we move towards containerization, right, this part does get changed and I believe, simplified for this modern world. The other advantage I haven't mentioned the containerization, but can't mention enough, is that we've also dropped the core requirements of the gateway down to one core here. So you will have, a DevOps pipeline, but you'll have application scoped gateways now too. So you'll have, it leads for a much finer grained control of your gateways with your backends using a more modern DevOps pipeline. But we're really not here to listen to my overview of the old DataPower. So, and I know Aidan wanted as much time as possible to share with you, and dive into the new stuff. So let's move on and let's go over to Aidan, who's going to take us through containerized DataPower.
Yeah, thanks, Chris. All right, so we could do an entire hour just going over the operator and all of its capabilities, but really we want to focus on the pipeline. And so to get there, I need to do just a bit overview of what does the operator offer as far as the APIs, how do you develop with it, and how does it deploy DataPower. So we'll touch on that briefly here first. The DataPower operator has two main custom resource definitions. The DataPower service is the primary API. So that is where you put what version of DataPower you want to run. It's how you define all of the domains you're going to deploy. And that's pretty much your your main interface. The DataPower Monitor is a second custom resource. It's used for monitoring of the pod events and gateway peering, which is important for API Connect, but we're not going to go into that in too much detail. Here at the bottom, you can see a super high level flow. You've got yourself on the far left. You work through the DataPower service custom resource. The operator picks that up and then deploys the stateful set of gateway pods on the right. So taking a quick look at what a DataPower service looks like, this is about as minimal as it can get here on the right. Just to show you the full YAML, you've of course got some metadata that defines the name and the namespace we're deploying into. And then under the spec, you'll see things like what version do you want? What license are you going to deploy? Here we've got a production DataPower following the 10.0 CD stream, which means that this operator will actually upgrade your DataPowers when we release new CD versions. So that's a pretty neat feature. You've of course defined the number of replicas you're going to deploy. Here we can see that's 3. The DataPower service also supports manual scaling as well as horizontal and vertical auto scaling. So really, this on the right is very minimal. Our spec is quite complex. There is full API docs online. I've got links to the reference material at the end of this, but I wanted to give just a brief intro of what it looks like. And when you do a configuration change, it's important to remember that you're working with config maps and secrets, and the operator is taking those and applying them to your gateway pods. So let's look at how that config actually gets into DataPower. We have a domains API, which is part of the DataPower service spec. And the domains API essentially is an array of domains, and you see things like the name of the domain. You see certs, which is how you mount your crypto material that would be used in your DataPower services, your multi-protocol gateways, your API gateways. And then the DP app is where all of the config maps get mounted. The config and local maps directly to that domain's config and local directory. So if you're familiar with DataPower, that should be a pretty logical organization. And something we actually added here recently is the passphrase secret. So if you're familiar with how password aliases work in DataPower, you'll know that in the domain settings for each application domain, you have to define a passphrase that all of your password aliases are encrypted with. And in containers, when you save that configuration, you have the option of emitting masked passwords into the CFG, which will then allow you to import that in another DataPower, and using that secret, you can decrypt those passwords. And so we've enabled that in the operator so that you can actually take configuration from your physical appliance, password aliases and all, and deploy them in Kubernetes or OpenShift, and have all of those password aliases get decrypted at runtime by DataPower. So it's a really nice parity item that we've added recently. And then, yeah, just to touch on again, you're mounting config maps and secrets. So you're deploying a base DataPower image. It's primarily just the firmware and of course the file system. All of your multi-protocol gateway config, your API gateway config, your secrets, that's all mounted at runtime to the pod. You of course have the option to build your own DataPower image, but really we're trying to steer people towards using the config maps and secrets approach because it's much more flexible in the long term. So let's talk about how you develop in DataPower containers. Chris touched on kind of what it looked like in the physical realm, or even the virtual machine realm, but how do we do that in containers? So really the high level process here is you're going to set up a local working environment. We recommend working on your own laptop. It's a great small form factor to work with, since the DataPower container can run with pretty small CPU requirements. You then would basically create your container, mount your relevant directories, config, local inserts, as we saw before. You can access the container's CLI by attaching to the container. You can enable the web GUI so that you can load up your browser on your laptop and access DataPower's web GUI interface. You can either import existing services you've already got from another appliance, or develop right there in that container. Then you can save your configuration, and using those mounted directories, those configuration files are then emitted back to your host file system, which you can then version control. So following through that example, basically here's a just the basic run through of the commands of how you could do this. So we'll set up a brief working directory called dpdev. We will create config local inserts directories. A very important step here is changing the permissions on those directories to make sure that DataPower, when it boots up and mounts those file systems, that it has permissions to actually write the config back. Because when you create those directories, they're going to be owned by your user, not the DataPower user. So we need to make sure that you enable those directories to have full read-write permissions to allow that other DataPower user to write back to those directories. You could certainly lock it down a bit more, but this is a great way just to get started on your own laptop. The next step is, of course, to create the container. There's more that you could do here, but this is kind of the bare minimum I would recommend. You do, of course, need to accept the license. So you do that with an environment variable. The next environment variable is DataPower Interactive. That lets the CLI shell connect to the container standard out and standard in. That's what enables the Docker attach capability. Then you see the volume mounts from your working directory to the file system locations inside the container. Then you see we name the container dpdev, and we pull an image from ICR, which is IBM's container registry. And in this example, we're pulling the DataPower Limited, which is the free edition of DataPower and version 10.030. So this would, because we're running it in interactive mode, when the container boots, you will be dropped right into the CLI, and you can log in with the default admin username and password. You would be presented with standard startup log here. You can enter config mode, write memory, and I would recommend writing memory out here to get an idea of what the file system looks like in your host file system when those files are emitted. So let's take a look at that. So we haven't made any changes. All we did was start the container, mount certs, config, and local, and then write mem. And this is what's emitted. So you do have the self-generated web GUI private key insert. You've got in the config directory, auto startup and auto user. Those are the default domain startup config. And then you have the default CFG, which references those other two files. And then local can be ignored here. So now from the CLI, let's enable the web GUI, since most likely you would be developing inside the web GUI, or at least importing config in this local dev environment. So we'll do that with one command. Next command there is just creating an example domain and then writing mem again. This will generate that domain in the CFG. And then here at the bottom, you'll see in that config directory, we now have a new directory underneath called example and example.cfg. So the purpose of walking through that is to understand where the files are placed inside the container in those mounted directories, and how you can then take those files out and version control them. So you need to understand what's the pattern of how DataPower lays down those files, and what do they look like. There is a distinction to make between your default domain and then any application domains. So the default domain will always emit its config in autostartup.cfg under the root config directory. It's unique here that the actual default configuration is not in the default.cfg file, it's in autostartup. The application domain, however, will be in a CFG file named by that app domain. So if you had a domain called app, you would see a directory under config and then app.cfg. And then here down at the bottom, I'm giving, basically the pattern of what everything would look like. And then we also have the local files. They follow a very similar pattern. Any local files in your default domain will be in the root local directory, and then application domains will be nested underneath a domain for that name. So basically, let's think about how we would then take a DataPower container that you're developing in on your laptop, take those files out, put them into version control, and then deploy that with a CI/CD pipeline. The important thing to remember is that what you're going to be deploying in Kubernetes is primarily going to be DataPower service custom resources. That custom resource is going to reference config maps and secrets. And so the output of your version control or your CI/CD pipeline is most likely going to be those config maps and secrets. You of course would have the DataPower service custom resource YAML, but long term that's probably not going to change as much as your config map contents. The one thing to remember here is that generally speaking, your crypto material may not want to be stored in version control for security purposes. So a lot of times what we would recommend is persisting the config and local files in version control, and then storing the secrets elsewhere, such as a vault store. So this is basically your high level flow. The nice thing about having your working directory that you're running your container in version controlled is that when you commit changes in your version control system, and then you go back into your container and deploy another service or make a change back in your version control system, such as using Git, you can run a Git diff and see that there's a new multi-protocol gateway added, or I changed the port of this frontside handler. And it's very easy to see in that CFG because they are just flat files stored in this version control system. So really the magic is once you've got the CFG and your local files is in version control is how do we get that through a CI/CD pipeline into Kubernetes. And the thing to remember is that for your config files, the CFG itself, those are created directly into config maps. The DataPower Operator documentation linked towards the end of this presentation does have a full working example of basically how do you set up a domain, how do you configure those config maps in the local file system. The local directory, because it is basically a blob of JS files, XML files, things like that, what we recommend is tarballing all of those files together and then putting that tarball into the config map. All right. Let me see, I do see some questions here, so let me just take a look at those before we get too much further.
I was just going to feed you that second and third questions here. The one from Emmanuel, we first talk about sometimes they try to save configuration on DataPower. Says configuration modified but not yet saved. They lose their configuration. I'm assuming this is specifically in the containerized world. I'm not sure that the context could be.
Yeah, that is tricky. So the DataPower will it will try and reconcile what configuration has been changed and alert you if something is missing. So sometimes, depending on how objects can reference other objects, it can say that there's something modified when maybe there isn't. It's hard to say without taking a look at any data. I would say if anything ever looks awry, certainly just reach out to us and we can try and help you out.
I mean, something that's definitely a PMR please.
Yeah, yeah.
When you hit save, it says it's modified. You hit save configuration. It should do something. You shouldn't lose your configuration changes. So it could be space. It could be as anything. The next question was Sebastian. Are there any considerations regarding the configuration of a gateway peering setup between two DataPower on Docker instances?
Okay, that's a really good question. So, and I want to kind of frame this. What we're talking about here is primarily just the DataPower Operator's functionality and how it works with the DataPower pods. In API Connect, there's a second operator that is part of this ecosystem. You've got the API Connect operator working in tandem with the DataPower Operator. And for gateway peering specifically, the API Connect operator will, here, let me go back to taking a look at, okay, this one. So the domains API. If you've deployed API Connect or an API gateway through the API Connect operator and DataPower Operator, and you came and looked at the DataPower service, you would see a domain element here for the API Connect domain. And in that domain, you would then, of course, have a bunch of different config maps referencing the main API Connect domain config, gives you your API gateway service and things like that. As part of the API Connect operator's configuration of the DataPower service, it also mounts a few startup scripts that are responsible for, so as each pod comes up in the stateful set, that pod will use the headless service of the stateful set to discover the other pods in the stateful set. So if you've got a stateful set of 3 pods, first pod comes up, there are no other pods yet, so it will generate its gateway peering config as its own pod. Next pod comes up, it discovers the other pod, generates its gateway peering config for those 2 pods, and then they sync. And then the third pod comes up, it discovers the other 2, rinse and repeat. So there are, basically the short answer is the API Connect operator is, configuring the data powers as well. So, it mounts config that isn't explicitly talked about here that helps set up those gateway peering. One thing to mention is that the DataPower monitor controller in the DataPower operator will monitor the state of all of the pods in the stateful set, and we'll try and make sure that the gateway peering config and the peers that are defined in that peering is all correct. So, for example, if you've worked with API Connect before, you've probably heard of stale peers as a topic. So that what happens is, you've got that gateway peering config that's generated at startup, and it references the pods that were there with those IP addresses that they had when that pod came up. But if those pods go away or are moved to a different node in the cluster, the IP address is going to change. And so that reference to the previous IP address is now basically a stale peer. And that can cause issues with gateway peering. And so the DataPower monitor will basically go in and look at each of the pods and make sure that all of the peers are correct. And if they're not correct, we will invoke an API that clears the peer list and makes that pod recalculate its peers. So that sort of helps in that scenario.
Hey, a couple yes/no questions for you here.
Okay.
Can these DataPower containers access secrets stored in OpenShift?
So I'll say yes, but we need to clarify what access means. The secrets, for example, here in this domain spec, there's one certs directory, or I'm sorry, one certs element defined, and the secret name is example certs. So you would expect that in the same namespace or the project in OpenShift, you would have had a secret created called example certs. And when the pod is scheduled, that secret is mounted to that pod so that the DataPower can then access the contents of that secret. The DataPower pod itself cannot reach out to OpenShift and access secret material. It's only the secrets that are mounted to the pod when it is created.
Cool. A couple more. Would I be able to deploy data? Well, the answer is going to be yes, but DataPower is a container in AKS or GKE. So Amazon and Google.
Yes.
Yes. Okay. We got a yes, no.
You can deploy it anywhere that runs Kubernetes.
I'm going to let you say. I'm going to let you. I think I'm going to let you say no now. Are there any operators available for 2018 gateways?
Yes, that is a no. So if you're familiar with 2018, you would have used the Helm charts to deploy API Connect and DataPower. The DataPower Operator documentation actually has a migration guide. If you are coming from v2018 with Helm charts, we have a migration guide that walks you through basically, here's what you would have had in the Helm chart. Here's how you move that to an operator-based deployment on v10. Yeah, so take a look at that. But yeah, no operators for 2018.
So, but another person actually answered that. Tiller and Helm for APIC 2018. Oh, Sebastian, who earlier had asked a question about the deployment of the peering setups on the two data powers and the load balancing and all that, has amended his question, and then I think we do have to move on with your subject. He forgot to mention that these are outside of the K8's cluster, his data power and Docker. So he needs them to be able to have two endpoints working on a kind of an active config, so we can share tokens between the two separate data powers, which are in different data centers.
Okay. Yeah, there's a lot to unpack there.
Yeah.
I mean, you can definitely have, you can have peers, across data centers. I mean, before we were in the container realm, you would have two physical appliances, and you would configure those two appliances to talk to each other, to be part of a peer group. Here in the v10 world, your peers are always going to be part of the stateful set. The stateful set is kind of the container for those pods, and that's how we define what the peer group should actually look like. So you wouldn't necessarily split, the pods in your stateful set across clusters, or, for example, have a pod in a stateful set try and peer with a pod running somewhere else. It's not quite the pattern we're going for.
But again, is it necessarily when you're talking about, say, OAuth token peering, right? With the I'll say it, Reddit's under the covers there, right? With this generic Docker, I can see it working.
Yeah, I mean, it all comes down to just making sure that your keys and certs match across the two pods. We actually have a pattern that has been used in IBM Cloud API Connect reserved instance to support external gateways. So if you want to run your API Connect and maybe even one set of gateways in the cloud, and then you want to run another set of gateways on your own cluster in your own data center, there is a way that you can configure the API manager in one cloud to talk to the gateways in another cloud. It's all making sure that those secrets on either side match. That's really all that it is. It's mostly when I was talking about the peering. The peer group is defined by the stateful set. So you would have one peer group in one data center and another peer group in another data center.
Yeah, and as I said, that would be a best practice, and it also involves latencies. There's a lot of things that would get advantage by defining it that way as a best practice. Especially around API, Connect with the chattiness of the clustering. So that's actually great. But great questions. I do think we want to move on here.
Yeah, yeah, it's a good side discussion. All right, so getting back to the pipeline here, one thing that is really neat about moving to a version control system and starting to work with pipelines to deploy your configuration and your data powers is that it allows you to very easily, separate your deployments. So you can have, a version control repository. Let's just use, GitHub, for example. You could have a GitHub repository that has your DataPower config. It could have 10 domains in it, a bunch of services in all those domains, and say as you iterate through making changes and developing new services,
Hi, Aidan. We cannot hear you.
Can you guys hear me now?
There we go.
All right, so sorry about that. Okay, I'll try and play that back. So you might have a set of services that you want to flow through different environments, such as a development environment where you are developing your services, flow that through a non-prod environment. Maybe it goes through more testing, SQA, and then deploy into production. And that can all be automated in a CI/CD pipeline. A best practice here would be to use different branches in your version control system to basically define what environment gets updated when that configuration change is made. You can then use basically your DataPower service custom resource to be that key that says any changes to this DataPower service custom resource goes to this cluster or this namespace or project in this cluster. And it's just a way to organize your deployments. All right, so let's talk about some of the nitty-gritty details of building. So you could have each branch of your repository mapped to a deployment environment, which is basically what we saw on the previous slide. Your repository itself is going to consist of the local and config files for each DataPower domain. What would be needed, and this is probably going to be kind of specific to your own pipeline and your own clusters, but we do have some examples in our there's a link I've got later on I can point you to for how to do this. But anyways, you'll need some scripts to package those files into config maps. There's lots of different tools out there that you can use for this. The high level to remember is that your CFG in the config directory, those CFG files get directly pushed into config maps. So if you're familiar with the kube control or the OC CLIs, it's basically just going to be kube control create config map from file. Here's a CFG file, and you're good. The local files are a bit more complicated because again, you have to tarball those files. A, to save space, because config maps do have a size limit, but B, that's how we've defined our API. And so you'll need some scripts to take those directories and package them up, and then apply updates to those config maps in your cluster. And then here, this is a link when you do have access to the slide deck. This is a link to that full example of creating all of those resources necessary to configure a domain. It's got examples of how you create the config map for a CFG file, how you package a domain's local file system into a tarball, and how you put that tarball into a config map. And then it also walks through the secret, the steps to configure your secrets for your certs directory. So that's all contained with this example here. Really worth trying out. It's a pretty straightforward example, but walks through basically all the steps you would need. And that is basically the pattern of what you would automate in a pipeline. All right, so let's talk about some best practices. We've got two slides here, and the first one is focusing on the DevOps side. So, because you're going to be deploying into a containerized environment, whether that be Kubernetes or OpenShift, it makes sense to develop inside your container. It ensures that you have a consistent environment. There are differences between DataPower Physical and DataPower Virtual and DataPower and containers. So, some of those differences are nuanced, and having your development environment directly mirror what you're going to see in Kubernetes or OpenShift is really valuable. Of course, you can version control your domain configuration and local file system. As I touched on earlier, when you make a configuration change, you can see that in a diff. If you're working in GitHub, you can use pull requests and review these configuration changes with your team. Next, the container development environment that we saw at the beginning, use that as your template for your repo architecture. So what you put into GitHub or GitLab, wherever you're hosting your resources, use that environment as a template. So it should be very easy for a developer that joins your team to clone that repository, basically start a DataPower container that mounts the file system that's in that repo, and their DataPower comes up with all the config that they need to work with. So if you map those together, then it's really easy to develop. And then it is worth noting that each domain, because of the way the DataPower file system is structured internally, each domain is going to have a subdirectory in the version control repo. So that actually makes it pretty easy to see where changes are being made and what domains are being affected.
Quick question quick question in the chat here. Just want to.
Oh, sure.
How can you use the debug probe when running in containers?
Okay. Yeah, sure. So the debug probe should work in containers. Basically, you would access your web GUI. There were steps earlier on enabling the web GUI, but say you've got your container running on your laptop. You can open up your browser on your laptop and go into, say, a multi-protocol gateway, enable the debug probe, send a test transaction through with curl or Postman or whatever tool you use, and then yeah, in that web GUI on your laptop, you'd be able to access the debug probe, and you can export that and move it somewhere else if you needed.
In that sense, DataPower is DataPower no matter what form factor. Right? If you're in the web GUI is the web GUI as it's always been.
Yep.
And the features are available like that.
Yep, exactly.
Okay. Back to regular scheduled programming. You can continue.
Yeah, thanks, Chris. Another really neat thing that I've started doing in my own development is having reusable snippets of config, either in your version control system or already in config maps in your namespace where you're working, that can be appended to domain specs as needed. So I know there's a lot of words there, but a really good example is, say there's a log target that you use to debug a service or a domain. So you could stick that log target CFG, just that little snippet, into a config map and have it sitting in your namespace, in your cluster. And anytime you need to debug a service, regardless of what domain it's in your DataPower, you could just append that config map to your domains API or your domain spec for that domain. It'll automatically perform a rolling update on your stateful set. Your pods will be brought back up, and now you'll have that log target. So it's a really easy way to, because you're working with these config maps that can be added or removed very easily, you can have things like enabling or disabling a service in a config map, just with CLI commands, and add it to your DataPower service spec. And it's a neat tool to be able to do this very easily. Another best practice is to avoid editing config inside the container while it's handling traffic in a production environment. This sort of is kind of a given. Changing configuration in prod is kind of a bad idea anyways, yeah. But it's especially a bad idea in containers. One of the big reasons here is that if you're going into a container that's in a pod in a stateful set, is that most likely, especially if it's in production or non-production, there are more than one pod in that stateful set. And if you are accessing one pod and making changes in that one pod, those changes are not being reflected in the other pods. So, because of that, unless you really know, what you're doing, or you specifically want to make one pod be different, going in and editing one pod directly is not a good idea.
I want to claim this is not a good idea, whether it's physical VMware or I can't think of where this would be a great idea.
Yeah, so there's a comment here about anti-patterns and restrictions on what can be done in the web GUI. So I guess let's clarify. The use of the web GUI that we've been talking about here is for local development. We're talking about running a DataPower container on your laptop or on a Linux server somewhere, and we're talking about you accessing that container, and you're probably the only developer accessing it. You've got your web GUI up, and you can have free will to do what you need inside that container, save your config, and then move on to a Kubernetes cluster. I do not recommend, and I probably should have written this in one of these best practices, I don't recommend adding the web GUI to a container running in a cluster, which I guess it is kind of in the second to last bullet here. Enabling the web GUI inside the containers in a cluster is opening yourself up for the risk of one pod not matching the rest and config being out of sync. And the other thing to remember is that stateful set is a managed resource by the operator. So if say someone tries to upgrade the DataPower, any configuration changes that you applied directly to that pod are going to be lost unless you're using a persistent volume. They're going to be lost when that pod gets rescheduled with a new version. So there's a lot of reasons why editing the config directly inside the container, in the cluster is a bad idea. I should have clarified. I'll try and edit this slide, see if they'll let me edit this slide before they upload it for the final.
But your net here is look, let the operators handle the cluster and let them handle the deployment of the cluster. You're effectively editing and doing your configuration in your development environment and putting it into the pipeline, and then the operator handles the rest of it. And by the way, web GUIs in production, we don't typically even recommend that again in any form factor and things like that. There's a reason they start coming turned off, right? You want those extraneous things not available in the production side.
Yes, yeah, and a really good way to think about it is if you think about your DataPower containers running in a cluster, you should never have to touch them. You should never have to, access the CLI in that container or access the web GUI. It shouldn't even be enabled, but you shouldn't enable it and you shouldn't access it. Those containers running in Kubernetes or OpenShift can be left and let the operator manage it for you. If you want to deploy a configuration change, the best way to do that is through config maps. It's your safest bet. And then here finally on this last bullet is, if you've followed along the DataPower container story over the past few years, we had pitched an idea of basically building your own custom DataPower image where use a Docker file. You use a DataPower container image that we provide as your base. You add in your configuration in a Docker build. You create your new DataPower image. You push that up to your private registry, and you can deploy that. And that is still viable. And we do support that in the operator. You can provide your own image override and deploy your custom DataPower image. So that's totally viable. Many customers have already built pipelines around this, and it's certainly a good way to get started in the container world for DataPower. But I really want to try and steer people towards this config map based deployment because it is far more flexible. It has less downtime, and it's objectively better in my opinion. One of the downsides of the custom image approach is that anytime you want to make a configuration change, even if it's a one-line change, you have to rebuild a container. That container is not small. I mean, our DataPower containers are pretty large, and so you've got to rebuild that, push it up to a registry, and then when your stateful set actually tries to take that change, each worker node in your cluster has to pull that image down before the pod can be actually started. So you've got the downtime of waiting for that image to pull. And image pull times can be, a real hindrance to the speed of a rolling update. So mounting your config at runtime to the same base image means that the worker node doesn't have to re-pull that image because you make a one-line change. It just stops the container, mounts the new config map, starts the container again, and you're back up and running in a matter of seconds instead of waiting for a full DataPower image to be pulled across the network. All right, so here's our final slide on best practices. This is touching back on just DataPower Operator as a whole, not so much on the DevOps side. It's worth noting that DataPower Operator, or most operators in general, can be installed at namespace scope or cluster scope. Something to remember is that even if you are installing at namespace scope, there are resources that are still cluster scope. Those are your CRDs, your cluster roles, and your cluster role bindings. Those resources are needed by the operator, even if it's in a namespace scope. And so, basically what this means is that if you do want to isolate your DataPower deployments to namespaces, or you want to have, say 2 namespaces that have each their own DataPower Operator installation, that is supported, but a caveat is that they need to be an identical version. So if you're running, 1.4.0 in one namespace, the other namespace needs to be 1.4.0 as well. And if they're not, then the CRDs, the APIs that the operator uses to talk to Kubernetes and work with the DataPower, those APIs may change. There might be conflicts, and so it just gets into a really bad situation. If you do want to deploy, DataPowers or in the API Connect world, if you want to deploy API gateways to multiple namespaces, really the best way to do that is to install your operator at cluster scope so that it can manage more than one namespace, all from the same single runtime. It means that when you do upgrade your operator, you only have to upgrade one. You don't have to, schedule when you're going to upgrade, 5 operators across 5 different namespaces. And then the last one here is avoid editing the managed resources directly. So this is not so much as going into the container and editing DataPower. We're talking about the actual Kubernetes resources that the operator manages. The stateful set is the primary resource, of course. So you could, for example, after the stateful set is created by the operator, if you went in and say you edited the pod template spec to change the resource allocation for the container, Kubernetes would let you do that. You would see the rolling update start, and you would have your pods, come up with that new spec. But probably within a couple minutes, the operator would come in and revert those changes. And that is because the operator actively manages those resources. And that's by design. It's for the stability of the DataPower itself. And so we strongly recommend not editing those resources directly. And in fact, sometimes it is very helpful to do that. So we added a feature. It's a pause feature on the reconciliation. It allows you to pause the DataPower operator from managing that stateful set. That's a really, really useful tool if you do need to get in there and tweak something in the stateful set to troubleshoot. So it's a really great feature. It's got a lot of flexibility. I would recommend checking that out if you do need to make changes to the stateful set, but know that those are supposed to be temporary changes for troubleshooting. Once you disable that pause, it's going to go back to what it was, being actively managed. All right, and then here at the end, we've just got some documentation links. First link is the operator proper documentation. Next link is the DataPower gateways on IBM documentation. The third one here was some of the scripts I had mentioned earlier. There's a couple things in here so far. One is a must-gather script, which is useful if you've engaged our support team. But another script in here is for migrating configuration from a physical appliance to containers. So there's a script that will process a DataPower backup or an export.zip and generate config maps for you. So that's a really neat script. It's got some limitations, but I strongly recommend checking it out. If you do have questions or see an issue, it's in an open source repository, so feel free to open an issue and we can engage on that. But it's a neat script. It should kind of help see how you can work with that CFG in your local file system to generate those config maps and get your your migration started. And then here's my email address here if you do want to reach out after the session at any point. And that was everything we had.